So far we discussed previous VSTL codings, operators, packages, and test benches. And now we are going to see about a simulation part. That is the first an example is adders. So in adders, there is two adders we have. So design of half adder and full adder. So this is basically we discussed in previous videos about the half adder and full adder. But even for the coding, we have to do again. We have to see for half adder, there is a two input and a two output. So this is a basic logic diagram and logic. This is a black diagram and this is logic diagram. Actually, for for VHDL coding, you have to write it. You can write it in three part. One is data flow and behavioral and structural. So for data flow model, they used to write that Boolean expression, and behavioral model they used to write this truth table, and structural model they used to write logic diagram. Okay, so based on that, there will be even that is a calling components are available in structural program. It's a basic simple program made mainly you can use data flow, and if you know well in C program, then you can use behavioral model. For structural, if it is a big program, so big logic diagram, then you can go to structural level. So this is a half adder, basic half adder Boolean expression and a K-map. So this is a coding part. So this is data flow model for half adder. So first you have to write it entity HA is. So entity HA is means so entity is a header file, HA is a program name, then port A and B in input and sum and carries output. So end half adder. So the first part is over. Then architecture is a body of the program. HA underscore data flow. This is the body of the program name. Half entity half adder name is here and is begin. So S. So what is S? It is output. So input is A and B. So the input of half adder A and B. Output is sum and carry. So for sum and carry, you just write it as S and C. So S is sum. So what's the value? A XOR B and C for A and B. So end half adder. This is a basic data flow program for half adder. So this is half adder by behavioral modeling. So, so entity of half adder. So this is a basic. The first header file is same for data flow, behavioral and structural. So port A and B input and sum and carry is output and half adder. This is same. Then architecture body of the program. So here the name is equation they given. Half adder it's an entity name. Then there's a process. So behavioral model they put it as a process A and B and begin if A0 B0. If it is A0 B0 and sum 0 carry 0, else if A0 B1 and A1 B0. That means from the truth table they are writing. So we know the truth table. So this is the truth table. So when is 0 0 sum 0 carry 0, when is 0 1 sum 1 carry 0. Actually here the output sum and carry is same 1 and 0 1 and 0 when it is 0 1 and 1 and 0. So at the time the 1 0 and 1 0 it is same, so remaining places only the value is different. So similarly you see that a in 0, so sum 0 carry 0, else if a 0 and 1 are a 1 and 0, 0 and 1 1 and 0, at the time the output of the sum and carry is 1 0, else if a1 and b1 then sum 0 carry 1. So end if end process end equation. Okay, that's all, thank you. Okay, the still we have to go for structural modeling. So structural modeling, this is XOR gate entity. So XOR gate you have to give the input architecture. So XOR gate you have to write the program for XOR gate. XOR gate we know that two input one output. So architecture. So XOR gate means X XOR gate Y. Then AND gate. So AND gate also you have to write it because half order having XOR gate and AND gate. So two gates you have to write the coding before start the structural coding program. So this is the main program. So entity half adder is the port. So everything is same. You know that header file is same always. Then architecture structure is the body of the program. Of half adder is the entity title. Then component XR. Okay, the first XR component there we are calling this is a component port X and Y in bit that is output and component. So component and one port P and Q in bit are output as a ND component. So these are the components we are just calling. So whatever the input they use, the same input and output we have to use for calling the component and begin. So here the main program started x1. So I found that xr1, that is xr1 means why we put it xr1, why we are not put it as xr, because xr already there in the program, so we have to mention it is xr1 and one like that. Then port map, so here input, first two input, then output a and b, some those are, so actually you know that x and y is that, so this is the thing that automatically it will be come to here x and y is that. The next two and port to A B carry, then PQR like that. So in structure, so this is the main program for half adder. So similarly for full adder also you have to try it yourself. So say, same half adder and full adder. So actually this is a full adder. So this is a truth table for full adder, and so based on the logic diagram, the full adder have the logic diagram. So using two half adder, so you maybe you can write it for one half adder coding, so that you half adder coding will be called two times using like this. You know here x1 xr port map like that, half adder one, half adder two like that. You can call it, and you can write the structural coding for behavioral model. If you know the truth table, you know. So here see that 0 0, so 1 0 1 0, so 1 0, the three times they are repeated, so this 1 0 that they will be take it as you know the half order behavioral model coding how we completed else if program and so used. So like that 1 0 1 0 1 0 like you put it, and 0 1 0 1 and 0 1, that is also three times used. So this is thing also you have to use like that. When how, yeah, here I say already behavioral model. See a 0 1 1 0, then 1 0 1, someone carry 0 like that. You have to put it three times, and so what is the value of someone carry like that. Another else if, then another three times put it someone carry. So within the line we will be complete, so using truth table. Then data flow modeling based on the Boolean expression. So sum A XR B XR C in, and carry A B plus C B C plus C in. So using this expression we can complete the data flow modeling in flat. Okay, you just tried. It is good. Okay, thank you.